Ladies and gentlemen of Algebra 2, welcome to the last part of Unit 9, talking about solving rational inequalities. So you've been talking about rationals and dealing with that. So rational inequalities have a little bit of a different wrinkle to it. So let's kind of talk about what we're doing here. So what you want to do is look at the related equation and then set your denominator equal to 0 and solve. And then you're going to create a number line and use what you used from the denominator. Okay, so you're going to set the denominator equation to 0 and solve, and then you're going to sample each interval and see which is true and which is false, and then that's going to be your solution. Okay, so that's kind of what you're doing. So you're going to solve it, set the denominator equal to 0, and then you are going to break up a number line into intervals, test each interval, see which ones are true, see which ones are false. Okay, so let's kind of do it. All right, so we've got our steps up at the top, so that's nice. So now what we want to do is look at solving this, so 7 minus 2b, and the first thing I would do is subtract 5b over to the other side. So you're looking at where is this thing going to be equal to 0. So I subtracted 5b over on that side. So this would become 7 minus 7 over b less than 0. Okay, so now to get a common denominator, I would say I would multiply this one by b over b. So now let me change colors here. So that's going to be 7b over b minus 7, like that. So now I've got a common denominator. Technically, I multiplied this by 1. So this is going to be as 1, 7b minus 7 over b less than 0. Okay, so if I factor the top, that's 7b minus 1 over b less than 0. So now taking a look, this is solved. All right, so take a look at the denominator equation and set it equal to 0. So that's going to be kind of my breakup, and then see where I'm going from there. So kind of what this means is I take b equal to 0, so b cannot equal 0. So then on my number line, I'm going to go to 0. I'm going to draw a line down it. So I'm looking at negative and I'm looking at positive, and I'm seeing which numbers are going to be true in this situation. So if I take a number like negative 1, which is in the negative, and I test it, I put it in here. So I take 7, negative 1 minus 1 over negative 1, and I see, is it less than 0? Well, that's 7 times negative 2 over negative 1, so that's going to be negative 14 over negative 1, but that's going to be a positive 14. Is that less than 0? No. So this does not work, okay? This fails. So now I'm going to test a positive number. So I'm going to test 1. Why? Because it's really, really easy to do. So, change color here. 7, 1 minus 1 over 1 less than 0. So 7, 1 minus 1, 7 times 0 over 1. Is that 0 over 1? Is that less than 0? So we've got kind of a predicament here where I've got 0 less than 0. Well, that's obviously not true. So let's take a look at kind of what that means. So for negative 1, that's going to be a 0. So that's where I want to put an open hole. Okay, so what I want to do now, because it's a solution, because it's a 0, I want to put an open hole there. And I want to test one more number. I want to go to the outside. I want to see if what I can do with like a number like 2. So if I take 7, 2 minus 1 over 1, oops, that's going to be 7 over 1, which is false. So that means this is going to be, I'm all turned around. So this is false. Over here was false. What about that little area in between there? Well, that's between 0 and 1. So let's test that area. So let's test this little area, and I'm going to try like a 0.5. and see if that's true. So if I take 7 and then 0.5 minus 1 over 0.5, let's see what happens. So when I do this, that becomes 7 negative 0.5 over 0.5. So that becomes negative 3.5 over 0.5, which ends up being negative 7. Is that less than 0? Yes. All right, so this little gap from 0 to 1, that becomes my only range that's true. So my solution, after all that noise, after all that mess, is going to be, my only solution is going to be 0 less than x less than 1. That is my range right there. Now, recap what I did. Okay, I did 3 things actually. 1, I set it equal to 0, solved it, simplified it as much as I could. So I took the denominator, set it equal to 0. That's where I got this line. Okay, then I took the top and I simplified that. So I figured out that, one of the zeros was going to be 1. So then I tested each range. I tested smaller, I tested in between, and I tested bigger. And I had to figure out which one of those was going to be less than 0. Okay, so you're going to do 2 things. Figure out the denominator, figure out the numerator, figure out your zeros, figure out your wholes, and then that's going to break it up, and then that's where you're going to test your limits. So let's take a look here. All right, so the first thing I would like to do is solve this a little bit. So I'm going to get 2 over 8a. I'm going to multiply this first thing by 2. Because I want a common denominator. So if I multiply both the top and bottom by 2, it's like multiplying by 1, which is fine. And then I'm also going to bring over 1/2 so it's greater than 0. So now I've got 7 over 8a minus 1/2 greater than 0. So now I need to make one more switch here. So this becomes 7 over 8a minus, and over here I need to make a common denominator. So that's going to be 8a, that's going to be 4a minus greater than 0. So switching into one big would be 7 minus 4a over 8a greater than 0. So now this is about as simplified as I can get it. So what I want to do is set the denominator equal to 0. So 8a equals 0. So a is going to equal 0. Set the numerator equal to 0 to figure out my actual solution or zeros. So 7. Negative 7. So a is going to be equal to 7 over 4. So my range, my gap here is going to be 0 and 7/4. Okay, so when I go back up to my number line, so if I go 0, 1, 2, 7/4 is going to be right here. All right, so I'm going to have a line there at 0 and a line at 7/4. All right, so that's at 7/4. So now there's 3 zones, there's 3 areas I need to mess with. I need to mess with over here, I need to go in between, and I need to go in here. And I'm looking for where is everything bigger than 0. So that's what I'm dealing with. So I'm going to take my function here, 7 minus 4a over 8a. I'm going to test that for a couple different options for a and see which one of them might be bigger than 0. So I'm going to test a point. So if I test negative 1, let's see what happens. So that's going to be 7 minus 4 times negative 1 over 8 times negative 1. So that's going to be 7 plus 4 over negative 8. That is going to give me negative 11 over 8, so that doesn't work. So that's a no. All right, so now I'm going to test in between. So let's test 1. Why? Because 1's nice and easy. So 7 minus 4 times 1 over 8 times 1. That's going to give me 3 over 8. That's a positive, so that works. Okay, from 0 to 7/4 works. All right, so that's a good one. That's a plus. That's a check. That's the one we like. So now we got to try a little bit bigger and see what happens. So if I try 2, so if I go 7, let me switch colors here. 7 minus 4 times 2 over 8 times 2. So that's going to be 7 minus 8 over 16, negative 1 over 16. That does not work. So the only range that works is from 0 to 7/4. So my solution, the only area that where it's bigger than 0 is from 0 to 7/4, or 1 3/4 if you want to be technical, which I hope you do. So that's what I'm dealing with right there. So I got to simplify everything. Now, simplify everything. Okay, figure out your zeros, figure out your wholes, set up your range, and go. All right, so now if I bring this over, so that's 1 plus 5 over y minus 1 minus 7 over 6 less than or equal to 0. So, a lot going on here. My common denominator is going to be 6y minus 1. So that's going to be 6 times y minus 1 plus, this is going to be 6 times 5 minus 6y minus 1 is going to be 7 times y minus 1 less than or equal to 0. All right, so all I did was try and get a common denominator. So now I can start putting together these top things. Okay, so on the bottom, I'm going to get 6 times y minus 1. On the top, I'm going to have 6y minus 6 plus 30 minus 7y minus 7. So that simplified becomes minus y plus 30 minus 13 is going to be 17 all over 6 y minus 1 less than or equal to 0. So now I'm simplified. Okay, so now what I do here is I take the bottom, set it equal to 0, figure out where my hole is. So that's going to be y minus 1 equals 0, so y at 1. So at 1 I'm going to have one line. Then I'd set the top equal to 0. So there's going to be my other gap at 1 and at 17. As long as I did that correctly. Whoa. Sorry, I back up. That's supposed to be a plus 7. So that's supposed to be a plus 7. So that's actually not going to be 17. That's going to be 31. Sorry, my mistake. I know you're yelling at me. You're going, geez, Heeren, what the heck is wrong with you? So this becomes 31, 31, 31. So my gaps become at 1 and 31, really. So I know this number line doesn't do a whole lot of help for you. So if you wanted to kind of skip and see what you can do. So, I mean, if I go like 0, 10, 20, 30, 40, something like that, you can manipulate the number line to make it any way you want. So remember, I've got my gap here at 1. I've got a gap here at 31. So now that's kind of my range. So what I'm trying to figure out is where is everything less than 0? Okay, so I want negative y plus 31 over 6y minus 1 less than or equal to 0. So I've got 3 ranges to check. I've got less than 1, okay? Then I've got from 1 to 31. Then I've got bigger than 31. Okay, so I've got less than 1. Then I've got from 1 to 31. Then I've got bigger than 31. So less than 1, I mean, for crying out loud, 0 is right there, take 0. So if I take 0, so that's going to be 0 plus 31 over 6 times 0 minus 1. So that's going to be 31 over negative 6. That answer is obviously less than 0. Okay, so that one checks out. That one's good. So now if I take a number in between, so if I take, I don't know, take 10 or something, I don't care. Well, you know what, if it's 1, let's go simple, I'm taking 2. So if I go negative 2 plus 31, all I did was pick some number in this range. Negative 2 is nice and easy. I can handle negative 2. So if I substitute that in there, that becomes 29. This becomes 6 times negative 3 is negative 18. That's going to be negative. That area checks out. All right? So now, last spot, I got to go bigger than 31. So if I'm going bigger than 31, I don't care what number you choose. Let's see what happens when I do 40. So if I go negative 40 plus 31 over 6 times 40 minus 1, that is going to give me negative 9 over 6 times 39. I don't care about a number. I care about if it's positive or negative. That's going to be negative, so that's going to be, so all these are going to work. So all these areas are going to check out. So my solution is going to be everything except what would give me a 0 in the denominator, which is going to be 1. So every area worked. Every area was a solution. So my solution is going to be y cannot equal negative 1. That's my answer. That's all I'm doing. That's my answer. So that's my solution for that. Everything else works. Y can't equal negative 1. That's it. So factoring and everything else need to be pretty strong here. All right, this one's a little bit easier. Not too bad. If I bring everything over right away, well, let me kind of see if I can put everything together here. So 3x, 5x, 15. 15x is going to be my common denominator. So 15x, that's going to give me 5. 15x here, that's going to give me 6. You know, that's going to be 3 times 2. Now if I bring over 1 over 15, that's going to be x over 15x less than 0. So putting this all together, 5 minus 6 minus x, that's going to be negative 1 minus x over 15x is less than 0. So now, denominator, 15x equals 0, so x cannot equal 0. So there's one slot at 0. Now I set the top equal to 0 and see what happens there. So negative x equals 1, so x and negative 1. So there's my lines at 0 and at negative 1. So this one should work a little bit easier. 0, negative 1. There's my line, there's my line. I've got to check each one of these gaps and see if they're true or false. I'm looking for smaller than 0, so I'm looking for negatives. So again, simple function, negative 1 minus x over 15x less than 0. So if I can't take negative 1, I go to the next simplest and I go negative 2. So negative 1 minus a negative 2 over 15 times negative 2. So negative 1 minus a negative 2 is going to be positive 1 over negative 30. Technically that's negative, so that area works out. Okay? So now I'm going to take my next piece, which is going to be in here. I'll take negative 0.5. So I will take negative 0.5, so I'll go negative 1 minus negative 0.5 over 15 times negative 0.5. And again, I don't care about what the actual number is. I care about is it positive or negative, because that's what I'm trying to figure out. So top is going to be negative 1 minus a negative 0.5 is a negative 0.5. 15 times negative 0.5 would be negative 7.5. So that cancels, that cancels. This is actually going to be positive, so that one doesn't work. So that's a no. Last piece, I need to go bigger than 0. Bigger than 0, I'd go 1 just because 1 is the easiest. So if I go 1, going 1 here, so that's going to be -1 minus 1 over 15 times 1. So it's going to be -2 over 15. Is that negative? Yes, so that area checks out as well. So now looking at this, I've got x less than -1, x greater than 0. There is my 2 solution areas. All right, take your time with this, play around with this, come talk to me with questions, and like I said, take your time, break everything down as simple as you can.